Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to SpaceVerse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, SpaceVerse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of SpaceVerse. Every giant starts small. Though you might not have seen them at their early stages, NASA's most advanced space telescope is now revealing the formative years of the universe, which were far beyond our reach until now. In June 2022, the James Webb Space Telescope captured its first deep field image, discovering a multitude of distant galaxies. These galaxies suddenly emerged from the darkness of time and space, revealing themselves in a way that made the universe seem much stranger than we ever imagined. For the first time, we were seeing galaxies that appeared to come from what we believe to be the universe's dark ages, challenging our understanding of the cosmos. And it wasn't just a few galaxies. The Webb Telescope found hundreds. One of these fascinating galaxies was discovered by an Austin astronomer named Stephen Finkelstein. He named it Maisie's Galaxy as a tribute to his daughter because they spotted it on her birthday. Initially, Finkelstein and his team thought that this galaxy had formed almost immediately after the Big Bang, according to cosmic timescales. They estimated it to be around 290 million years after the Big Bang. However, after using more advanced equipment to analyze the galaxy, they found out it was actually about 100 million years older than their initial estimate. This new discovery didn't take away its title of being the oldest galaxy ever observed. It was formed only 390 million years after the Big Bang. This discovery is significant because it gives us a glimpse into the early universe, a time that was previously inaccessible to us. The James Webb Space Telescope has allowed us to see further back in time than ever before, revealing details about how the universe developed. It's fascinating to think that these ancient galaxies, some of the first to form after the Big Bang, have been hidden from our view until now. The insights we gain from studying these early galaxies could potentially reshape our understanding of the universe and its origins. Moreover, the discovery of Maisie's Galaxy opens up many questions about galaxy formation in the early universe. How did these galaxies form so quickly after the Big Bang? What does this mean for our current models of cosmic evolution? The James Webb Space Telescope is not just providing answers but also raising new questions, driving the quest for knowledge even further. However, the title of the oldest galaxy ever observed might not belong to Maisie's Galaxy for long. Finkelstein's team is currently evaluating about 10 other galaxies, any of which could be even older. We're seeing a rise of massive galaxies faster than we previously thought, said Fabio Pacucci of the Harvard-Smithsonian Center for Astrophysics. Some of these early galaxies are estimated to be just tens of millions of years old. This rapid formation could have significant implications for our understanding of dark matter structures, known as halos, which are thought to shape early galaxies according to our current cosmology. Indeed, there are still some problematic and potentially model-busting early universe candidate galaxies. The first of these may be a class of galaxies identified by a team of scientists at the Swinburne University of Technology in Australia. This team discovered galaxies with billions of solar masses comparable in weight to the Milky Way from just an estimated 750 million years after the Big Bang. These galaxies are 10 to 100 times bigger than those previously seen in this era and are packed into structures 30 times smaller than the Milky Way. Even more intriguing is that these galaxies appear to be hosting far more stars than we ever thought possible. This discovery suggests that our understanding of star formation and galaxy development in the early universe might need significant revision. The sheer size and star density of these early galaxies challenge our current models and hint at a much more complex and dynamic early universe than previously believed. Indeed, our basic understanding of how massive structures develop over time has been challenged by these findings, shaking up the cosmological standard model. Remember what Michio Kaku said last year when the Webb Telescope first revealed these early galaxies? That's the issue. The James Webb Space Telescope is turning everything upside down. Suddenly, we might need to rewrite all the textbooks about the universe's beginning. Typically, it takes billions of years to form a galaxy like the Milky Way, with its 100 billion stars, many of which are billions of years old. But the Webb telescope has found 6 galaxies that existed just half a billion years after the Big Bang and are up to 10 times bigger than the Milky Way. That shouldn't be possible. There shouldn't be primordial galaxies larger than the Milky Way at only half a billion years old. Something is off. We might need to revise our theory of the universe's creation. That was last year. Since then, not only have we discovered more distant galaxies, but Webb has also recently detected Milky Way-like galaxies at the universe's edge that, according to current physics, shouldn't exist. Many early galaxies found by the JWST were filled with glowing gas so bright that it outshone the stars forming within. These new discoveries show just how common such luminous, gas-rich infant galaxies were when the 14.8 billion-year-old universe was only around 2 billion years old. Observations now indicate that almost 90% of these galaxies exhibited extreme emission features, meaning they were full of that glowing gas. This discovery, showing that so many early galaxies were brimming with bright, glowing gas, suggests the early universe was far more active and dynamic than we previously believed. The presence of these extreme emission features indicates intense star formation processes, contributing to the rapid growth of these early galaxies. As we continue to explore these findings, we may need to completely rethink our models of galaxy formation and evolution in the early universe. While studying these early galaxies, astronomers found the most distant example of a galaxy that looks like our own Milky Way. When the universe was just 2 billion years old, the newly discovered spiral galaxy Ceres 2112 had a bar of stars and gas running through its center. This is surprising because our Milky Way, a spiral galaxy, also has a similar bar. Scientists think this bar in the Milky Way rotates and funnels gas into the galaxy's center, triggering bursts of star formation. Previously, astronomers believed this structure marked the end of a galaxy's early development and was expected only in older, more mature galaxies. Observations from the Hubble Space Telescope led us to think that the early universe had very few barred galaxies. But now our understanding is changing. New data from the Webb Telescope suggests that barred spirals might not have only formed recently in the universe. The discovery of spiral galaxy Ceres 2112 shows that galaxies similar to ours existed almost 12 billion years ago when the universe was just 15% of its current age. Ceres 2112 is observed at a redshift of 3, indicating that its light took almost 12 billion years to reach the James Webb Space Telescope. This is surprising because galactic bars were thought to appear about 4 billion years after the universe's birth. The standard model of cosmology predicted that the early universe's conditions should have prevented the formation of barred galaxies. But here we are with new evidence challenging that belief. Furthermore, even the theoretical forecasts from cosmological simulations struggle to replicate such phenomena at these early stages. So, what's the deal? We need to pinpoint which crucial element might be absent in our models, as suggested by one of the scientists involved in the discovery. Now, if you find that astounding, consider this. Experts estimate that 85% of all matter in the universe is dark matter, a mysterious substance that doesn't interact with light and remains indetectable through conventional means. Dark matter is believed to have had a profound impact on galaxy evolution and star formation as early as 380,000 years after the Big Bang. However, the latest findings from this discovery indicate that galaxy evolution, particularly in the case of Ceres 2112, was primarily driven by ordinary matter, not dark matter, when the universe was approximately 2 billion years old. Yes, it's a significant breakthrough, affirming that the evolution of this galaxy was governed by baryons, the everyday matter that comprises everything we perceive, rather than dark matter, despite its prevalence. It's a fresh and unexpected revelation. At this juncture, it seems that we can anticipate nothing short of groundbreaking revelations from the James Webb Space Telescope. These are exhilarating times. We find ourselves in an era of substantial cosmological transformation, with the mysteries of the universe now within our grasp. And that's it. As we come to the end of our exploration into the mysteries of the cosmos, remember that the universe is a vast and ever-changing tapestry of wonders. Join us on SpaceVerse as we continue our journey through the depths of space, uncovering the secrets of distant galaxies and the origins of our existence.